What should a business do in the event of a natural disaster like a flood or a tornado or an earthquake? Well, for companies that want to stay in business, they've got to learn to manage that risk as well. Let's begin. Back in the 90s, I had the opportunity of working at Blue Cross of California, and that was located in Woodland Hills, California. And it was also in the 90s where we had a 6.7 earthquake that was referred to as the Northridge earthquake. And the epicenter was within very few miles of our offices at Blue Cross of California. And one of the elements of security isn't just against attackers or people who might compromise our information systems. We also have risk against things like outages or natural disasters. For example, a fire could totally disable a company. A power outage could do the same. Any type of data or data communications failure. So maybe, for example, we're connected to a service provider for internet connectivity for our customers to be able to access and interact with us, and for whatever reason that's disrupted. We could have hardware failures. And as I mentioned, we also could have natural disasters, such as the earthquake, like I mentioned, or hurricanes, or floods, or tornadoes. And part of having a really good BCP, which is an acronym that stands for Business Continuity Plan, and a business continuity plan is going to help an organization predict and then plan for potential outages of any critical system or service that might impact business, and then setting up a plan of dealing with those issues if they do or when they do arise. The first step an organization would want to take in getting ready to handle any one of these situations is doing what's called a BIA, a Business Impact Analysis. And this next line identifies a big part of a business impact analysis is to identify our critical systems that we have in the company. So as part of this business impact analysis, we're not trying to identify solutions for all the potential problems that may come up. We're simply seeing how any one of these items may impact our business. So for example, in a business impact analysis, we would have identified our critical systems. We would have identified the assets that could be harmed or damaged based on one of these incidents occurring. We'd want to identify dependencies. For example, let's say we have a critical business system that's C. But in order for C to work, we have A and B that also have to be in place, and they feed each other. So in this example, if C is a critical business system that we have to have up and running, we can't do business without it, and if C won't operate without B and A, that would make B and A dependencies that C is relying on. So as a result of our business impact analysis, we would identify those dependencies. And then as we formally put a plan together that we can use in the event of an incident, and our plan, what we would do is implement some solution to make sure C gets up and also B and A, because they're all critical to the overall business continuity for the ability for the organization to stay in business. Now, as part of the business impact analysis, we're also going to be looking at the RTO. That's our recovery time objective. So in the event something terrible happens or there's some outage, the RTO calculation, whether it be hours, minutes, or days, how soon until we can recover from it, that's also to a very large degree going to impact the business. For example, if you and I have an online business and we have customers that visit our site every day, if we're down for 2 weeks because we have a really long RTO, that's going to be a huge impact on the business. And as a result, the business impact analysis may say, you know what, that RTO doesn't work as far as maintaining business continuity. Because if we're down for 2 weeks, we may not be able to survive as a company. So the recovery time objective would be part of the business impact analysis, as well as the RPO. For example, if we only have backups once a month and we lose a whole bunch of data back to that restore point, we might identify in the business impact analysis that that doesn't work. We need to have a more frequent backup system. For example, we may need to restore to the last 6 hours or the last hour or the last 10 minutes. And the business impact analysis could help us identify the impact to the business if the RTO and the RPO were, for example, too large of numbers, too long to get back in operations. And with our RPO, if our last good solid backup was like 2 weeks ago, that may result in the business impact analysis saying that will not be acceptable. We cannot survive if our backup is that old. So we may decide to tweak these values so they won't have such a devastating impact on business. And the business impact analysis may go through several scenarios. And the important aspect of this is we're thinking ahead and we're taking a look at, okay, if this happens, what's the impact on our business? And the planning, so we have some idea at least of the impact, is the major function of a business impact analysis. And part of the business impact analysis is also going to identify the risk. And that will usually be in numbers. For example, quantitative. which we've discussed in a previous video in this course. So at the risk, if some failure happened, it might cost us, for example, $10 million. And that is really important to know, or at least have a general idea of the cost involved of the risk of these different situations, because it's very likely going to help us justify, from a business perspective, some of the controls that we can put in place, like fault tolerance and high availability, or alternate sites that we can then go ahead and pay for to help reduce the risk of a loss of that magnitude. Now, besides just quantitative, there also could be qualitative, where we're estimating, or I like to call guesstimating, the impact that an outage is going to have on our business. For example, how many customers might we lose? So continuing on the business impact analysis, lost customers. Are we going to lose customers? And if so, how many? And what's that going to cost us? Are there going to be fines involved? I'm also going to put consequences here. I'm running out of room, so I'm going to put CONS, short for consequences. Because we may have a business system that if we don't provide the services that we're saying we will, there could be fines involved. And at the end of the day, the real goal of doing this business impact analysis to identify our critical systems, to identify the actual loss that may happen, and run through various scenarios, is that we're going to build something called a BCP, which stands for a Business Continuity Plan. And in a perfect world, the general flow would go like this. We'd have a business impact analysis to identify the risks and the critical systems and all that stuff over here on the right-hand side. Then we would identify strategies that could be used to help mitigate the risk of one of those outages actually causing that impact on our business. So here we're just simply identifying some of our options. Some options are more expensive than others. For example, if we want a hot site, now a hot site is a full redundant site. It's up 24/7, and it's got all the equipment, software, networking, and everything else, just like the primary site, but it's used as a backup location. And all the data that you're currently processing is currently being processed at the primary site and this backup hot site. So the switchover, if there's a natural disaster, for example, at the primary site, and we want to switch over to a hot site, it can be done very, very quickly. Now you might imagine, what's the problem with having two fully operational data centers or two fully operational sites? You've got to pay for both of those. So another strategy might be a warm site. Now with a warm site, we don't have all of our live production data coursing through the veins of this backup alternate site. With a warm site, we do have computers at that location, and we very likely have the network infrastructure ready to go. But in the event of a disaster, we would go ahead and take our backups and restore the backups to the gear and the systems at the warm site. We would move our personnel to that warm site and then be up and running. Now, a warm site is slightly less expensive than a hot site. And the negative of a warm site, it takes longer to get a warm site up and running and in production than it would a hot site. So the hot site is the most money. I'll put $3 symbols there. A warm site cost a little bit less, and the disadvantage is time. And the third option here is a cold site, and that one is even less. A cold site is pretty much a facility. It's a facility, but there's not computing equipment there, the systems aren't there, it's just a location. And in the event of a disaster where we have to move to that cold site, we would first of all have to fill the cold site with networking equipment, with our systems, then restore backups to those systems, and then go ahead and start working from that alternate site. And because we don't have all the computer systems already in place all the time, 24/7, sitting at the cold site, it is less expensive to maintain because it's pretty much just a facility that can be used in the event it's needed. So after we identify strategies for helping mitigate a risk of some type of outage due to a disaster, we then create a disaster recovery plan, and that's the acronym for it, DRP. So the DRP is identifying which strategy or strategies we're going to be using to help compensate or mitigate the risk of having a significant outage of our production system. And once we have our plan in place, we'd absolutely want to test and verify that it actually works. I mean, seriously, let's think about this. If we put a disaster recovery plan together and we purchase a warm site or even a hot site, we absolutely want to make sure that it really will work. We don't want to just check a box that says, yeah, we've got our disaster recovery plan. We want to make sure we have a working disaster recovery plan. And then the reality is we need to go ahead and consistently monitor and update. Because here's what happens. Let's say it's January 1st and we have a perfect disaster recovery plan in place. We've tested it. We know it's good. everything's happy. And then in February, we modify some of our internal software and systems, and we take out B as an input component to C, and we use X. So now we have this new input that's used by C. So the dependency of C is A and X. But if we don't monitor and say, oh my goodness, we now need to change our disaster recovery procedure because now we have this additional asset, X, this system, this mission critical system that has to be compensated for as part of our disaster recovery plan. So we might have a review, like for example, every 6 months or every year of our disaster recovery plan, just to make sure that it's solid. And we would also want to do periodic testing and verification of our disaster recovery plan as well. So in the big picture, the business continuity plan may involve one or more disaster recovery plans, depending on what has happened, which event. For example, if you just have a power outage, that's going to be much different than we have a flood that's taken out the entire facility. So we may have specific disaster recovery plans, and they're all feeding into this big goal called business continuity. Now, we identified our critical assets with the business impact analysis. And there's also this feature here called IT for Information Technology Contingency Planning. And then in the disaster recovery plan, we might have IT contingency planning within that. And the IT contingency planning is really focused on like a single system and the details of that single system. So for example, maybe this is system A, and let's say there's another system of B, which is a separate system, and maybe we have a dependency between the two, where A feeds into B, and that makes both of them critical for our overall business continuity. So part of the disaster recovery plan says, okay, we need to make sure we have both of these systems in place. And then on an individual system level, we have IT contingency planning. For example, within this system right here, which I'll go ahead and put in green, how do we improve the fault tolerance of that system? Well, we might use RAID or clustering, or if there's a failure of that hardware for system A, how do we deal with that? How do we repair that? So the business continuity is broadest in scope regarding keeping the company up and running. And the disaster recovery plan is going to have groups, if you will, of mission critical systems that have to be online. And the IT contingency plan is focusing just on a single system. Another critical aspect that I've discovered in the event of a disaster is communications. For example, when I worked at Blue Cross of California in the 90s, and there was that disaster, fortunately it didn't take out the entire building. But if it had, where would I, as an employee, a staff member at Blue Cross, where would I go to find out what we're going to do? Are we going to go to a hot site or a cold site? How do I know? So part of the disaster recovery plan, which serves the overall business continuity plan, is going to detail the communications that need to take place. For example, who are the first responders going to be? That should be identified as part of our overall plan. How do we communicate to our employees? Who talks to the press? That should all be identified in our business continuity plan and disaster recovery plan. And it's very likely the only people authorized to talk to the press and make official communications about what's happening with the company would be senior level management. So it's very likely I would have a call or some communication from my manager to me as an employee who would say, here's our plan, here's our next step. And if anybody from the press or anybody else contacts you, this is the number and name to go ahead and refer them to. And that way the company as an organization can have one nice clear message that's being communicated to the public. And also if we have a plan regarding who's supposed to contact who internally within our organization, it's going to help reduce a ton of confusion. And by reducing the confusion, it can help improve our recovery time to getting up and running and back in business, which is what business continuity plans are all about. Now, the review process for making sure that our business continuity and our disaster recovery plans are actually working or they could work is we're going to periodically walk through them. And a tabletop exercise, also sometimes referred to as a structured walkthrough, is when you have all the right parties involved. For example, you've got somebody from Human Resources, you've got somebody from Business Unit 1 and Business Unit 2. You've got the right people from Information Technology there. You have the correct senior management. And what you do around a table is you say, okay, great, let's presume that we just lost power. Or let's presume that our building was just demolished by a natural disaster. And then you walk through it. And it would involve specifics. For example, the manager or director of business unit number 1, we might say specifically to him, okay, we have to go to a warm site in our tabletop exercise. We're going to a warm site. And what are the 3 critical systems that you've previously identified that have to be up and running? And walk us through, just logically, the process for bringing those systems online. Now, all those details, which have been analyzed and identified in a business impact analysis, should be available to that director or manager at that meeting as we're now logically going through the process. And the other item, when possible, is to take this from a tabletop exercise, a what-if scenario, walking through each logical step and actually doing each logical step. Now, in the event of a cold site or a warm site that doesn't yet have the computers in place to do all that work, a scenario and a preparedness check may be the best that we can do, but at least we want to make sure all the players who are going to be involved in our disaster recovery know exactly their roles and are ready to respond in the event a disaster occurs and senior management has identified it's time to kick in our disaster recovery plan. And when the disaster strikes, the time for planning has expired. That's why it's really important to make sure the planning and preparation would go in beforehand to an effective business continuity and disaster recovery plan. I've got a government question for you. Let's say in the United States that something really terrible has happened to the president. Maybe he's in a full-blown coma or he has passed away. My question is, what happens if something negative like that happens to the president? Now, even if you're not from the U.S., it's very likely that you're aware that the vice president would go ahead and step in. Now, the reason that happens is because somebody planned for it, and that's called succession planning. And the same thing needs to be planned for in a business as far as our business continuity plan and also potentially our disaster recovery plan. And that way it's clear. If we do lose a senior officer in our organization, we want to make sure it's clear exactly who should step in and who has the authority to go ahead and make those decisions in the absence of that specific senior manager. So really this is contingency planning based on human resources, and it's usually referring to the senior executive level. There's a technique that we're very likely going to see in most organizations that have a strong business continuity need, where they want to keep operations running in the event of a failure or some minor problem. They want to be able to take a licking and keep on ticking. And to do that, they're often going to use a technique called high availability, and the acronym is HA. And that's done through redundancy. I remember in the movie Contact with Jodie Foster, the government built this spaceship majigger thingy at location A. And then secretly, in another part of the world, they built another spaceship thingy at location B. And one of the quotes from the movie said, hey, why buy one when you can buy two at twice the price? And that's really the only big negative in high availability is that it usually takes at least two or more devices to provide that fault tolerance. The ability to take a fault or have a fault, to tolerate that and still provide network or system services. That's what high availability is all about. So in the case of a hardware failure, let's take, for example, routers. Let's say a router has the ability to fail or an interface. Instead of just having one router between the users and their firewall, we could put two routers between the users and the firewall. So we have a connection that lets them talk to each other. We connect that to the switch as well. We'd probably have a switch on this side. And then we have router A and router B. And those are commonly referred to as an HA, a high availability pair, sometimes called a group. These routers also may be referred to as active standby, if that's how they're configured to operate. An active standby pair, where one's doing the work and the other is just there in case the first one fails to do the work. So in this HA pair, high availability, it's just an example of how we could implement fault tolerance and redundancy that's going to help the continuity of our operations in the event a single device fails. And the way it's pulling this off is with redundancy. So we're eliminating any single point of failure, at least here at the router. The router was a single point of failure. Now that we have two, and they're working as a group, as a high availability pair, we've eliminated the single point of failure, and we've mitigated loss in the event router A or router B decides to not work or operate. And that also includes the links. So for example, if this link between router A and the switch fails, router A could say, hey, I've got a problem. I don't have link on this interface. Router B would say, no problem, I'll take over and start forwarding traffic. And the goal is to be seamless or near seamless from an operations perspective. Another technique that can also be used for fault tolerance, however, it has some other benefits, is the concept of clustering. So this server right here, let's say we have three of them. Server 1, 2, and 3, and they're all cooperating together in a server cluster. So let's say Bob has some super high CPU intensive task that he's going to send out to this server farm, this cluster of servers, for them to do the work. If the job normally would take, for example, 60 minutes on a single server, because he's sending it to the cluster, that same job could be done in 20 minutes because there's three servers in the cluster, and those multiple systems working together are going to increase the overall power that's used for Bob's rendering or Bob's CPU intensive job that he's sending over to those servers. An example may be, let's say Bob is concerned that everybody is following company policy and using complex passwords. And a complex password should be at least 8 characters or greater. It should be alphanumeric. It should have special characters, the kind that look like you're swearing, like pound symbol, @ sign, exclamation mark, and so forth. It should have upper and lowercase alpha characters. And some password systems allow spaces as well. So the more complex we can make a password, the better it's going to be. Now, ideally, check this out. If you and I want to make sure that the entire company is doing that, we should implement technical controls, like group policy, inside of our system that forces the users to use complex passwords. So what Bob could do as an administrator, he could download the hashes that are representing the passwords from all the users in the company. And then what Bob could do is he could try a brute force attack against all of those passwords. And he could do that offline because he has a copy of all the hashes from the security database. Now, doing a brute force attack on every single hash, one by one by one, that takes a lot of energy, a lot of CPU. So what Bob might do, he may take a dictionary list of common passphrases and terms, and let's say his dictionary list is 11 million entries long. And what he could do is he could go ahead and create hashes for those 11 million passwords / passphrases and create what's called a rainbow table, and then use the rainbow table against the dumped hashes, and that would go a lot quicker. Now, you might also be saying, well, Keith, an attacker, if he got access to that database, could also use the same technique. And that is absolutely true. But in this case, it's authorized because Bob's the administrator and he's just verifying whether or not passwords can be cracked, and maybe somebody has an easy password in there somewhere he's looking for. So in creating the rainbow table, if one server took 60 minutes to go ahead and do it, if he sends it out to the cluster could very likely do it in 20 minutes because we're grouping multiple servers together to deliver some service to Bob. In this case, he's building a rainbow table and he's leveraging the CPU on all the devices in that cluster. Another concept where we're going to use multiple servers is the concept of load balancing. So let's say we have on our DMZ, we've got 5 other servers. 1, 2, 3, 4, 5. And let's say, for example, that Lois out here on the internet is a user and she goes to www.url.com, whatever the name is of that site. And let's say, for example, she's returned via DNS a single IP address, 23.1.2.3, as an example. And then when Lois makes an attempt to connect to that server, she can hit something called a load balancer. And what the load balancer do, it can round robin. It can say, okay, the first request goes to the server. And then we have Jim, who makes another request. And that goes to the next server. And then Jane, she makes a request. And the load balancer says, oh, you're going to the third server. So it can distribute the load across multiple devices. And that will give overall better performance for the set of users who are using those services. Now, the load balancer doesn't just have to be round robin. First you, then you, then you, then you. It can also be fed information on which device is the least busy at any given moment. And then it could load balance by giving the task or giving the connection request to the lowest utilized server at that moment. Load balancing can also be done across a set of routers or firewalls to distribute the load of that traffic. So as traffic is going, for example, from Bob, and we'll put Karen up here. So we have Karen and Bob as 2 internal users. As they're going out to the internet, the network can provide load balancing so that some of the traffic goes over one path, maybe over router A, and other traffic goes over router B. Again, that's an example of load balancing using multiple devices to share the load or share the work. And at the same time, if a single device fails, if it's a high availability pair, the one that's still working and functioning can go ahead and support all the traffic. And in that case, that pair would usually be referred to as like an active pair, because both devices are used during production time. And if one of those devices fails, the other one can still be active. As opposed to active standby, where one device is doing all the work, the other device is just sitting there hoping he doesn't have to work, but will kick into gear if that primary device that was currently active, if it fails, this guy will go ahead and go active, and then he'll start forwarding traffic. Another fault-tolerant technique that we can use to help improve availability is something called RAID. It's redundant array of independent, or it depends on who you read, inexpensive disks. Now let's imagine that we have a single server here. So there's no fault tolerance from a server perspective, but we do want to have fault tolerance for this server's hard drives. How do we do that? Well, as with most things with fault tolerance, the first thing we're going to do is buy more than one. So let's say we have a 1 terabyte drive. So instead of just having 1 terabyte drive, we would have 2 terabyte drives. So there's drive number 1 and drive number 2. And RAID comes in several flavors. I'd like to chat with you about a few of those. RAID Level 0 is named appropriately because it has no fault tolerance. With RAID Level 0, it does striping of the data across 2 different drives. So let's say, for example, we had a large file. What it would do, it would write some here, some here, some here, some here, some here, some here. And that's good for improving throughput and speed because we have 2 disks with 2 separate platters and 2 separate heads that can get that data faster for us. But for fault tolerance, it really is RAID 0 because it does 0 for fault tolerance. If we lose either physical drive, we're in trouble. But that's what RAID Level 0 is. I also want to point out that with striping, we get full use of those drives. So if this is 1 terabyte and this is 1 terabyte, we would have total usable space of approximately 2 terabytes. And again, the challenge is there's no fault tolerance here. The next RAID option, we do have fault tolerance. It's called RAID Level 1. And with Level 1, it's called mirroring. And here's how it works. Here's drive 1, and there's our second drive. And with RAID Level 1, we're going to mirror everything. If we write data to drive number 1, it's going to write that same data, the exact same data, to drive number 2 for the purpose of fault tolerance. And so if either physical drive fails, that remaining drive, in the event of a failure of one drive, can still function. So our disk space, if we have 2 1 terabyte drives, is still 1 terabyte because one is completely mirroring the other one. The next one I'd like to talk with you about is RAID 5. And what it does is it does striping plus parity. And to do this example right, we're going to need 3 drives. So I'm going to put 1, 2, and 3. So we've got 3 physical drives. Let's say they're all 1 terabyte in size. And at the end of the day, these 3 drives are going to give us 2 terabytes worth of storage. And what this allows us to do is we can lose any single physical drive and the RAID group can still operate. Now, if we lose 2 drives at the same time with RAID Level 5, we're done. It wasn't designed to support the failure of multiple drives in that RAID set, but it can tolerate a single drive failure. And if we take a look at a bigger picture, if we had RAID Level 5 and we had 10 drives and they were all 1 terabyte each, our usable disk space would be 9 terabytes. And it isn't that it just took one of those drives and said, I'm going to use you just for parity. It's actually striping data across all the drives, and it's also distributing the parity information so that it can recover any single drive across all the drives. So with RAID Level 5, if all of your drives are exactly the same size, your total usable capacity would be the quantity of all those drives minus the capacity of a single drive. And if we did have these 10 drives, we could lose any single physical drive and still survive it. Well, of course, we keep pushing the envelope of what we can do and how we can accomplish it for fault tolerance, and they came out with RAID 6. And RAID 6 also uses striping and parity, except not just single parity. It's RAID Level 6, it does double parity. So at RAID Level 6, let's say we had 10 physical drives in our RAID group. With RAID Level 6, it's possible to lose multiple drives, for example, 2 drives, and still have that RAID set function. So in most RAID solutions today, because we want the fault tolerance, we're going to be using RAID Level 5 or RAID Level 6 as our approach. And in our planning, as we take a look at the continuity of operations and business continuity and high availability, a solution like RAID 5 or RAID 6, is a good first step to help protecting that system, specifically its hard drives, from being a single point of failure. Now, for true fault tolerance of that system, we probably need 2 systems. So if we had to order, for example, the best way to do it, we could say RAID for fault tolerance of a disk system. And if we had a cluster of servers, or even if we had 2 servers and we were load balancing across them, that could provide us fault tolerance as well. And it's very likely in each of those servers, we would probably use some type of RAID system for fault tolerance of the hard drive in each of our clustered servers. And maybe as part of our disaster recovery plan, we said, well, we can do this for fault tolerance, but what we really want is a hot site. And we may get pushback saying, you know what, the risk is simply not great enough to justify the cost of a completely redundant site with redundant hardware and all of our data at that location. So maybe we say, well, what about a warm site so we could actually bring our data over and start it up? And we may get pushback on that too. There may not be justification to have a separate physical facility that's near ready to go. And so maybe we say, well, how about a cold site? And again, it's all based on justification of the loss. What is the business impact of a total disruption of service and does mitigating that justify the cost of any of these off-site locations? And it may turn out that senior management may come back to us and say, you know what, you're going to do RAID on the servers and hope for the best. Maybe a little load balancing in the network. And it's at that point that you and I have to trust senior management that they have taken a look at the business as a whole, and that they are investing the time and energy and resources to mitigate the risks where it makes business sense to go ahead and mitigate those risks. And in some environments, we may have a server that doesn't have any fault tolerance, and that may be okay too, because if a server goes down and there is no significant business impact about that server going down, and the recovery time objective is 3 or 4 days, and that's acceptable, it's possible we might not even be asked to do RAID as fault tolerance for the disk subsystem. Again, it just depends on the business model and the type of risks that we're trying to mitigate. Back in my early days, one of my saddest stories from the early days was when a customer came to us as the administrators and said, I've lost some data off of my server and I need to go ahead and restore it. It's from one of the business units. And we said, well, let's take a look at it. It turns out that this business unit was responsible for their own backup system. They had purchased one, they had turned it on, but it wasn't working correctly. And it was so sad. It's funny now, but it's so sad to sit right there in front of the customer and tell them there is no backup. I felt like crawling into a hole. It's just terrible. Now, the solution to that is to have, first of all, a plan. What is our recovery point objective? If a system goes down, if we lose the hard drive, what have you, and we have to go to backup to restore, at what point do we want to be able to restore from? From 5 minutes ago, or from a day ago, or from a week ago? And we would identify the RPO based on our business impact analysis. If we have to go back 5 weeks for the last backup, that's very likely on a critical server to have a huge impact on business. So we need to identify what the RPO is, and then identify a frequency of backups that honors that or can fit into that recovery point objective. Now, regarding the actual backup types, we could do a full backup, and it's just what it sounds like. We're going to back up every single bit of data. And the challenge with the full backup is that it takes a long time to actually do. It might take 4 or 5 hours to do a full backup. But if we wanted to, we could do a full backup every single night, and then we'd have all that data. Another option is to do a full backup with a combination of incremental. And the way this works is pretty cool. We start with a full backup. Let's say it's Sunday. So Sunday, midnight, we do a full backup of the system. And then on Monday, what we do is we do an incremental backup. And what the incremental will do, it'll say, let's just back up the data that has changed since the last backup was performed. So maybe like 5 or 6% of the data changed since the last full backup, and that incremental backup on Monday would back up that 5 or 6% of data that had changed. And then Tuesday rolls around, and the incremental backup is going to say, you know what, let's just back up the data that changed since the last backup. In this case, the last backup was on Monday night. So maybe 2% or 3% of the data changed since the Monday night backup. And so the Tuesday incremental just backs up that. And then Wednesday rolls around, and the incremental again is simply going to back up the data since the last backup of any type, which in this case was Tuesday. Now the challenge with this is, let's say that Thursday morning comes around and we need to restore all the data. To restore the data, we're going to restore, first of all, our full backup from Sunday night first, and then the incremental from Monday, and the incremental from Tuesday, and the incremental from Wednesday. And after we've restored those 4 data backup sets, we've now effectively restored all the data. Now the pros and cons of this. The Monday night, Tuesday night, Wednesday night backups, maybe they only took 30 minutes or 45 minutes fairly quickly because they didn't have to back up all the data, just the data that changed since the last backup. So the benefit of a full/incremental combo is it takes less time to go ahead and do the backups nightly. The negative, however, is that it takes the most time to go ahead and restore, because instead of just restoring a full backup and having everything ready to go, you got 4 backup sets to restore in a specific order. Now another option is called a full and differential combination. And a full/differential goes like this. On Sunday, we'd do, for example, a full backup. So it takes its 5 to 7 hours or whatever it takes to do its backup. And then on Monday, we do a differential. And the differential says, I'm going to make a backup of any data that has changed since the full backup. So at first glance, this kind of looks identical. It's like, well, that's what we did with the incremental. Where we start seeing the difference, though, is on Tuesday night. On Tuesday night, we do a differential again, and it says, I'm going to back up the data that's changed since the last full backup. And then on Wednesday night, the differential says, I'm going to go ahead and back up the data that's changed since the last full backup. So as an example, if every day 5% of the data changed, Wednesday's differential backup is going to basically back up 15%, which represents all the data that's changed since the full backup. So the backup process every night is going to be slightly longer than the full/incremental. However, the benefit of a full differential is the restores. If we want to do a restore, we would restore the Sunday full backup, we'd restore our latest differential backup, and we're done. So those are some traditional methods that we could use for backup strategies. And based on the type of system we have, there's lots of really cool new inventions that have come out over the last decade, including backing up to the cloud, which with a big enough pipe can sync all of our data so that if we did have a system failure, we could restore all of our data. And using a solution, whether we're implementing it in-house or implementing it through a cloud service, could give us the ability, if we did lose a system, to restore to a new system the data just like it was, like a few moments before the original system failed. And that, my friend, is pretty cool technology. I have had a great time, and I'm glad you joined me for this video. I hope this has been informative for you, and I'd like to thank you for viewing.